Chapter 17, Example 2. Suppose that about 13% of the population is left-handed. A 200-seat school auditorium has been built with 15 lefty seats. Seats that have built-in desks on the left rather than on the right arm of the chair. In a class of 90 students, what's the probability that there will not be enough seats for the left-handed students? We're going to use our normal model again. In this case, we have a set number, those 90 students, and the 15 lefties. So, it is reasonable to assume the handedness of one student does not affect the handedness of another student. One person being left-handed shouldn't make the next person be left-handed or right-handed. And the 90 students can be thought of as a random sample because they're just all mixed up in that class. There's no order form going in here. Okay, 90 students are less than 10% of all students. .13 equals 11.7, the number of left-handers we'd expect. And 90.87 equals 78.3, the number of right-handers we would expect. Both of which are at least 10. I can use the normal model for the sampling distribution of 90 students. So our probability equals 0.13, and our standard deviation, sigma, will be the square root of 0.13, the probability of a left-hander, times 0.87, the probability of a right-hander, their complements, divided by our sample size of 90. And this will equal 0.035. We have a normal model of 0.13 and a standard deviation of 0.035. The probability that we run out of left-handed seats would be 15 over 90, which equals 0.1667. We'll have a z-score of 0.1667 minus 0.13 over 0.035, which comes out to be 1.05. So let's take a look at our normal curve real quick. We have 0.13, there's the 0.116, and we're going above that. So we shade to the right. A little bit more than one standard deviation away. So the probability that z is greater than 1.05 equals 1 minus 0.8531, which is the value from our z-table. This equals 0.1469. According to the normal model, there is about a 14.7% chance there will not be enough left-handed seats for the left-handed students. The probability that we run out of left-handed seats would be 15 over 90, which equals 0.1667.